there, excuse me, and welcome to your video on both your Quadrat handout and your diversity index handout. There were some discussions on the difficulty of this stuff, so I'm going to go through it, but just realize that this is the kind of thing where you simply need to read the instructions deeply in order to be able to do the homework. So I'm going to go ahead and take you step by step using some dummy data that I came up with. All right, so the first thing I'm going to go over is the Quadrat, which is the thing that has the bugs on it. So ignore the lines that are on there right now. Remember that this is a way of being able to estimate an entire population without having to count every single little thing that's there. When you get a homework like this, you need to read every word in order to be able to do it. So the expectation is that you have read this part up here, and you can see the diagram on the following page represents an area of leaf litter from a forest floor with a resident population of organisms. So in other words, it's as if somebody took a picture of the ground in a forest. There's 4 animal species, and there's also leaf litter that's there. And it gives you a definition of leaf litter. And then you're practicing the steps required in order to do a sampling of a natural population. So this is something that people who do this for a living actually do. All right, so let's go ahead and read the instructions. Number 1, decide on the sampling method. When you read this, it basically says the sampling method has been determined for you, which is you're using a Quadrat. Remember, we're discussing different types of ways to estimate a population. You really don't know of any beyond the Quadrat, but there are a bunch of others that we're going to talk about, including mark and recapture, deadfalls. We're going to talk about all of them. All right, it is step 2, excuse me, that you're actually going to start doing stuff. So you're going to notice it says mark out a grid pattern. So you need to use a ruler to do 3 centimeters intervals for the sampling area. And you can see it's a 6 by 6 grid. So in other words, you are going to create let me make this a little smaller. You're going to be creating a grid of squares, so 6 squares by 6 squares. And according to the instructions, you're going to see that they are 3 centimeters on every side. So this is not inches, it is centimeters. If that was your problem, reading is your issue. So 3 centimeters mark, 3 centimeters mark, blah, 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 blah. You create this grid. All right, so back to the instructions. Number the axes on the grid. So it's telling you that you have to select them in a random manner. You don't do gut feelings. The way that you do this is a numbering system. So the first thing you need to do is to set up your numbering system. And it tells you starting at the top left-hand corner, number the columns. And remember, columns go this way and rows go this way from 1 to 6. So in other words, you have 1 to 6 across and 1 to 6 down. All right, next instruction. Choose quadrats randomly. So here it tells you, see column of random numbers chosen. I literally highlighted one for you. You should have A, B, C, or D highlighted. I created a random set here, E. When you read this, it says the table above has been adapted from a table of random numbers from a statistics book. So these numbers were chosen in a truly random fashion. And then it tells you what they mean. The first digit refers to the row, and the second digit refers to the column. Rows go this way, columns go this way. All right, so you're going to write whatever column it was that I highlighted right there. Highlight the boundary of each selected quadrant with a colored pen or highlighter. So let's go ahead and go over how I did this. I pulled a separate one, that way you weren't just copying what I was doing in this video. So you can see my first square I'm going to be choosing is 2, 4. First number is the row, second is the column. 2, 4 is right here, and I highlighted it. The next one is 2, 2. 2, 1, 2. It's this guy. And so on and so forth. So as an example, 1, 5, 1, 5. So it is the row that it's in and then the column that it's in. Da 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 da. All right, once you've highlighted all of those, and you should have 1, 2, 3, 4, 5, 6 chosen in the column that I highlighted for you, decide on the counting criteria. Before you count, you need to establish your criteria, and here are the criteria that you can choose. You can choose that you're only counting the individuals if they're completely inside, only counting if they have a certain part inside, half individuals, maybe you're going to do decimals, and then you count the thing as a complete individual if it's half. So the one that I decided on was half of the object or more in the square. This is my personal rule. You may have a different opinion. So in other words, you need to choose one of these or make up your own as counting criteria. Now this says in your group, each one of you is doing this individually. So yeah, so you need to decide amongst your own self. And then you carry out the sampling, which is literally you count. So according to my criteria, as an example, the first square that I counted is 2, 4. So 2, 1, 2, 3, 4. In here, I counted 2 woodlouse, no centipedes, no false scorpions, 1 springtail, and 6 leaves. Again, using the criteria that I personally selected, that as long as half was in there, for example, that leaf counts, that bug does not, because only his tiny little butt is in there. Okay, so again, 6 leaves, 1, 2, 3, 4, 5, 6. One of those guys, one of those guys, one of those guys. So you literally just physically count and you fill in your table. Calculate the population density. You're going to use this formula. This says total number in all quadrats sampled. Number of quadrats sampled. All of you sampled 6. How do you know that? 1, 2, 3, 4, 5, 6. Times the area of the quadrat. Your area is right here. Area of quadrat, 0.03 times 0.03. Remember, it's in meters. When you multiply those two numbers together, it is 0.0009 meters squared. Again, I didn't have to think about this because it's literally in the instructions. All right, totals from the other side. So you can see the woodlouse, this got cut off here, but you simply add down, add down, add down, add down, add down. You can see here I had no centipedes, so that number there is 0. Okay, so this tells you right here. It even tells you each has an area of 0.009 right there. All right, so you do that for each one. So total number in all quadrats sampled for the woodlouse is going to be right there, and that's going to be 4 plus 1, that's 5, 9, 11. So that number for me for woodlouse is 11. So I'm going to put 11 on the top, and on the bottom I'm going to go 6 times 0.0009. Please remember to put, if you're going to put this into your calculator all at one time, you're going to put parentheses around that bottom multiplication in your denominator to make sure that it comes out correctly. So in other words, when you calculate all of this, the only thing that's changing is your numerator. The denominator will be the same for all of these. So you can see, because I am dividing by a number that's going to be pretty small, my numbers are going to be large. Also notice that I went ahead and rounded up to whole numbers. How you choose to round is entirely up to you. If you have 100.2 and you want to round down, that's fine. If you're like, well, part of an insect probably represents a whole insect altogether, you can round up. Just use the same justification all the way around. So these are the numbers that I came up with for my estimations. So here you can pretty much answer this question. Remember again how quadrats are done. You literally will take some stakes and string and kind of mark this out. So think about some problems that might happen if the bugs are moving around. Now, this one right here, carry out a direct count. Guess what that means? Count everything here. Literally go through and count all of it. There is nothing stopping you from dividing up the load. I will tell you that if somebody is telling you to come up with the leaf number, you are going to be the one that's counting the most stuff because there's a lot of leaves here. All right. And then you're going to compare what you calculated with your actual count and see how it's close. Okay, so that is how you do this one part. Here you have the Simpsons Diversity Index. I want to make sure you understand what this formula is right here. This is what it looks like when you actually write it out. That E means sum of. So when you're calculating this, this is for each species, and then you're going to add it all together. I am going to post a link of something like this that has been worked out, the actual diversity index, so you can take a look at that. In order to answer these, you simply read this, and you can see that this is an important part right here, and that helps you answer this first one. And then you have this guy right here. If you actually follow this step by step by step, it is going to take you through how to answer this. Where you're going to need to know how to actually do the Simpsons Diversity Index is right here. You will go ahead and, like I said, I will post a separate link on my website that shows a similar idea but different data and how they actually calculated the number, so you can see how to do that. But if you simply follow this step by step by step, you're going to be fine. The feeling I kind of get is that some of you, because you don't understand it right away, feel like you're never going to be able to do this. That is the nature of a course like this, and quite frankly, of courses in college. You're going to have to grapple with this, and to grapple means to wrestle. That means you can't expect to simply read it and automatically understand it and then be able to do the homework. That is not the nature of this course. This is stuff you've never seen before. If it was that easy, you would not have to take the class in order to take and pass the national exam. The act of learning takes effort, and that is where you have to read stuff. If you don't get it, you come see me during lunch, and you come with targeted questions. You don't come with, I don't get it, but you say, all right, what exactly do they mean here by n? Can you point out where that number is? And I'll be happy to do that. But you need to make sure that you come up with targeted questions. So anyway, hopefully that helps you with these two homeworks, and good luck.